Hi everyone, today we're going to be talking about z-scores in this set of notes. For your essential question for this notes, what does the z-score tell us? And then we're going to actually talk about what our z-scores actually mean. So this is a value that shows how many standard deviations a data value is from the mean. Then we have when our z-score is positive, this means that the data value will actually be above the mean, which is a good thing if you're above average. That's how we figure out above average. When the z-score is negative, then your data is going to be below the mean, making it an actual below the average. So when we have a z-score of 0, the data value is just going to be equal to the mean. There is no below or, so it's just going to be equal to it, no below or above. Then our actual z-score formula that we have, to find the z-score for data value in each of these sets, you're going to be normally distributed. It has to be normally distributed in order to find your z-score. So you're now going to use x, the data value, that represents the data value. Let me actually write this formula out first so I can show you what I mean by this. And so we have our x, which is the data value here. So we're always going to be putting in our data value. The mean, you have the mu right here. Remember that you might also see the mean being represented with the x bar right there. And then you have the standard deviation that we're dividing by. So then, for our first example, we're going to be using that formula. So I'm just going to rewrite it at the top over here just so I can not have to keep going back and forth and remember this. So a radar detector records the speeds of a group of cars that pass by. If the mean is 46 miles per hour and the standard deviation is 2.8 miles per hour, we're going to find the z-scores for each of these data values. So first of all, what we're talking about here, 52. We're talking about a car going 52 miles per hour. So that's actually one of our data sets here. So I'm going to go ahead and plug in the 52 for my data set, that x value. I know what my mean is because the problem told me what the average speed was for those cars, which is 46. And I'm going to divide that by our standard deviation of those average car speeds by 2.8. When I go ahead and put that in my calculator, I end up getting 2.14. 2.14. Okay, so what we want to do is we want to make sure we are writing these in complete sentences so that you guys know what the actual z-scores and the data values are actually representing. So for here, for this part A car's speed of 52 miles per hour is 2.14 standard deviations away from the mean. So what that means is that a car going 52 miles per hour is actually above the average of the mean of 46 miles per hour. So let's go ahead and try our second example here just to keep getting practice. So now we're talking about a car that's going 42 miles per hour. I'm going to go ahead and plug that in for my data set here, use the same mean, and divide by my same standard deviation. When I put that in my calculator, I end up getting a negative 1.43. So already having a negative standard deviation means that this car is going to be below the average. And we can see that because this data value, that 42, is less than 46. So I'm going to go ahead and write my sentence for this, which says a car's speed of 42 miles per hour is negative 1.43 standard deviations below the mean. And you can actually just not even say below on this case because you could just say the standard deviations from the mean here. Oops, I'm deleting that. Hang on a second. Standard deviations from the mean. The alternative sentence that would work as combine the below part. So an alternative sentence that I would like you guys to also write down is that a car's speed of 42 miles per hour is 1.43 standard deviations below the mean. So there I did not use the negative sign. I actually just stated below instead of having the negative sign. So you can use your sentence either way. If you choose not to use that negative sign, you need to be stating that it's below the mean. You can also, just like our first example, you can say that it is 2.14 standard deviations above the mean. So either sentence works. And then we are going to go on to our second example here. So the mean number of total miles ran last week by each number on the track team was 4 with a standard deviation of 1.2. So again, Our mean number of each of the track team was 4, and then we had our standard deviation of 1.2. If Clay's z-score was 2.5, how many miles did he actually run? So we have a z-score here that was also given to us. This time it's a little bit different because now we have our data value with our mean and our standard deviation. So we're going to plug in the given information to us. Well, we had a z-score of 2.5, so I'm plugging that in for the z. That stands for our z-score. I know that I have my, I don't have my data value because I'm trying to figure out the amount of miles that he actually ran, but I do have my mean of 4 and I do have my standard deviation of 1.2. So when I go ahead, now I have to actually solve this equation for x. I'm going to go ahead and multiply both sides by the 1.2 to get out of that fraction. When I multiply both sides by 1.2, I actually get 3 equals x minus 4. Now I still have to work to get my x by itself, so now I have 7 equals x here. So what this data value here actually means is that our runner, Clay ran 7 miles. And that's what I want you guys to be making sure you are writing these complete sentences, because that's what you actually need to know what's going on. It's asking how many miles did he run? Well, Clay ran 7 miles. Now let's go to our next example. We have a set test papers is normally distributed with a standard deviation of 5, and if Riley recorded an 83 with a z-score of negative 0.4, what is the mean? So if we're given different parts of this information, you guys, we can still use it to end up finding out each of these values. So again, I'm going to use my z-score formula. I'm going to plug in where the values I actually have. So I have a z-score of negative 0.4. I'm going to equal that to my data value, which was her score of 83. I'm going to subtract it from the mean, which I don't know. This is my question mark. And then I'm going to divide it by my standard deviation of 5. Again, I'm trying to get that mean, that mu by itself, so I'm going to multiply both sides by 5, and then I'm going to get that, getting it out of my out of my division there, which gives me negative 2 on the left side, and I still have my 83 minus my mean here. Well, I need to get rid of that 83, so I'm going to subtract 83 from both sides, making this a negative 85, equaling my negative mean. Divide by that negative 1 still, and that gets me an positive 85 equals my mean. So in this case, in this example, the mean was 85. The average was actually a score of 85. So Riley was below the mean, and we know they were below the mean because it was a negative z-score as well. All right, for our last example here, the heights of a group of trees is normally distributed with a mean of 14.3 feet. If the z-score for a 20-foot tall tree is 1.9, now we have to figure out the standard deviation. So this is our question here. So again, I have my z-score formula, which is my data value minus the mean divided by the standard deviation. And now we get to plug in those values. So our z-score was the 1.9, which means that we're above the average. And we have our data score value of a 20-foot tree minus our mean of the 14.3, and we're trying to find our standard deviation. We do have to multiply by our standard deviation on both sides in order to get out of our fraction. So this is going to be left with a 1.9 times that standard deviation that we actually don't have left out yet. But we are going to do our 20 minus our 14.3. You guys can go ahead and actually subtract that if you wanted to. And when you have 20 minus 14.3, you end up getting 5.7. And we still have this 1.9 theta over here. Well, in order to get our z-score by itself, we need to divide by that 1.9. And in our calculators, we see that we have 5.7 divided by 1.9, and we end up getting our standard deviation of 3. Okay, so that's how we manipulate these equations. We go through, we just kind of figure out the different values. Just plug in always what your given information is. You have to always be given 3 out of the 4 things out of that z-score formula. Again, go ahead and rewind anything that you guys need to look at, and make sure that you guys are writing sentences just like we did here and here of what our actual solutions actually mean. All right, you guys, until next time, thanks, bye.